Hello students. In this video I'm going to show you the steps needed to complete your second computer assignment. So we have some data. We have the y variable, the dependent variable, and we have an independent variable x1 as well as a second independent variable x2, and they're both trying to predict the same y variable. Y as in our dependent variable. The first thing we're going to learn is to calculate the correlation between the x value and the y, or the x and the y variable. So in Excel we can calculate the correlation by using this function. It is equals Pearson, bracket array1 comma array2. It does not matter which column we use or which variable we use for either of the arrays. I'm going to start with y, comma, highlighting all the x values. And there is our correlation. And we can do the same thing over on our second side. We have correlation equals, the function is equals Pearson, bracket, one of the variables, comma, the other variable. And this correlation is negative 0.78, whereas the other correlation was positive 0.959. Let's minimize that down to 3 decimal places. So there's our two correlations. The correlation for the value x1 is stronger. Both are strong. But this correlation here, this one here, would be stronger than this correlation over here. Let's change colors there. The correlation for x2 and y is negative, so it's there's a downward trend, but it is still quite strong. So let's calculate, or let's create a scatter plot. In order to create a scatter plot, we're going to highlight our data, including the labels x1 and y. Insert this scatter. We're going to click on this first one, and let's move it over here. Let's shrink it down a bit so we can see it. There is the scatter diagram for the first data set we have. We can do the same thing for the second data set. Insert and click on that first one, and there is our scatter for the second data set. We can notice that in the first data set it's going up from left to right, hence the correlation is positive. In the second scatter plot we have, it's going down. There's a negative trend, a negative correlation to that. One thing we can do, one of the first things we should do when we are looking at data sets is do a scatter plot to see if there's a linear trend. And we can see that both of the data sets have a linear trend. One of the things that we can do here is we can add a trend line to this data. And this is something that Excel will do for you automatically. To add that trend line, we right click on any of those dots, add trend line, and we want it linear. And we're just going to close that. There's this trend line. We can do the same thing for the second data set. Right click on one of the dots, add your trend line, and it's linear. So there's the two trend lines. For the first data set, the trend line is positive, going left to right. For the second data set, it's a downward trend. It's going down from left to right. Other things we can do in Excel is we can create or calculate the regression line. Remember, the regression line is the estimated value, so it'll be y hat, equals the intercept, if I can spell correctly, plus the slope times the x value. So we substitute in any x value multiplied by the slope, add the intercept, and we will get the estimated y value. Well, let's calculate slope and intercept. So to find slope in Excel, we're going to use this function, equals slope. Equals slope bracket. Then it's asking for all the y values, comma, all the x values. So let's go y, highlighting all the y values, comma, highlighting all the x values. Close your bracket, and there is our slope. Let's make that down to just 2 decimal places. The intercept, the y-intercept, the function in Excel is equals intercept, bracket, all the y values, comma, all the x values. Close our bracket, and there it is. Let's label that a little better. This is our y-intercept. And that should not be a percentage. There it is, 21.15. Now we can see on the trend line, as we drew before, that the y-intercept, that's where it crosses the y-axis. If we were to extend this line down to the y-axis, it would cross just above 20. And hence, that's where we get that y-intercept from. And it has a slope of 5. It's going to go up 1 and over. It's going to go up 5 and over 1. We can do the same thing over here with our second data set. We can calculate slope and the y-intercept again. So equals slope, bracket, all the y values, comma, all the x values. And the y-intercept, the function is equals intercept, comma, or equals intercept bracket, the y's, comma, all the x's. And that is our intercept. Let's narrow this down to a few decimal places. There, so the slope is negative, correlation was negative. In the first data set, correlation was positive, slope is positive. The y-intercept is 103, so if we were to extrapolate this line back to the y-axis, it would cross, at 103. So once we have the slope and the y-intercept, we can do other calculations. For example, if x equals 5.5, what does the y estimated value equal? So if x equals 5.5, for the first data set, what does y equal? Well, y is going to equal, the formula is intercept plus slope times x. So let's go equals, click on the value for intercept, plus the slope value times 5.5. That's our value for x. So there is the estimated value for x, or for y, if x is 5.5. It's just 48.85, and we can see that 5.5 is going to be right around here, and up here, going up, just under 50. So remember this trend line, that's the estimated value. We can do the same thing over here. Oops. If x is 5.5 for the second data set, it's using a different formula. It has a different, same formula I should say, uses a different slope and intercept. So the formula is equals, find that intercept, click on that value for intercept, plus the slope value, and because slope is negative, it's basically going to be adding that negative value or subtracting it, times the x value of 5.5. So if x is 5.5 right around here, it's estimating that the y value is 90.5, and we can extrapolate that up, and we should hit around 90. A couple other things to be aware of. Let's calculate residuals. I'm going to calculate residuals for our first data set. So one thing we need for our residual is the estimated y value. So y hat. So with this, we use this same formula, intercept plus slope times x. There's our intercept plus the slope times the x value. X, we're basically trying to determine what the forecasted value is when x equals 1. We know the actual value is 29, but the forecasted value would have been 26.2. So we can do that formula for the other 10, or which we can do because we want to copy this formula down. A little trick in Excel is, remember this formula is based on this value, which we want to change, and these values which we want to hold constant. So those values that we want to hold constant, we need to put a dollar sign in between E and that number 18. And same thing here, a dollar sign in between the letter and the number. And we're going to leave, in my case, we're going to leave D2 by itself. If we do that, we get it, the other forecasted values. Now, just to show that this 76.5 is the, we did a different formula process, we can go back and just type in the formula, intercept plus the slope times this x value, and there is that same value. Now let's calculate the residual. The residual is the difference between the actual value and the estimated value, or y minus y hat. So in this case, go equals. Any formula in Excel follows the same process. Go equals y minus the estimated value. Once we have that value, we can copy and paste this down, or we can, once our mouse changes to that plus sign, we can just drag this down and we get the residual values for all of the x values. For all of the, when x is 1, estimated or actual value is 29, estimated value is 26.2, the residual is 2.8. Let's look at this value here. When x is 6, predicted that the expected value for y is 51.4, whereas in reality that y value is 43. So there's a large residual. We can look at this on our graph as well. This residual, 8.4, happens when x is 6, and this difference here between the line and the dot is the one that has the greatest difference. Look at, oops, using the wrong graph. My bad. So there's the value of 6. There's the actual value of that dot, and that line represents the estimated value what y should be given the formula. And that difference, 8.4, is the largest differential, or largest residual. There's some other large residuals, but some are very close to that estimated trend line, and that is what the estimated estimated least square regression line is based on. The one line that's going to minimize the difference between the estimated y and the actual y. So let's just put that back there. One other thing we want to calculate is the coefficient of determination. Let's just bring that out there a bit. Remember, the coefficient of determination, this is r squared. So the correlation is the value of r. So the coefficient of determination is, click on the value of r, you shift 6 to get that hat symbol, and 2, which is a way to square this value. The coefficient of determination, as a percentage, 91.9%. So about 92% of the variation in y is explained by using x1 as a variable. That's how we interpret the coefficient of determination. So your second computer assignment is going to be very similar to some of the steps I've shown you here in this video.